Avery, you're online. What's going on? Couldn't come to class. Is Avery here? Anybody's online class here? Somebody's online. And definitely cannot hear me. Hello? Avery, can you hear me? Okay. How come you're not in class? Okay. So I just wanted to know why you're online. That's all. That's okay. All right. So you know that I'm doing the class like this. So if some kind of an emergency, you can be online. There's no problem with that. But don't make it a habit. It's not like when I say you have a problem, really problem. Okay. So for all those who are hearing me now, just that's the case. This is an in-person class. You cannot be online unless you have a good reason for it. Okay, so we talked about inheritance, and today we're going to go first through the syntax, then we're going to go to the animal thingy that we had before. So let's talk about the syntax of inheritance. So the syntax of inheritance says when you have a base class, any type of base class, okay, this base class has whatever it has, base. Okay, that's the constructor of the base class. The syntax says to inherit this to a new class, to get all the features of the new class, you say class, public, class, derived, public, base. So this is how you create a class out of another one. Now, what does it mean? It means derived will have everything that base has, and you add something to it here. Remember that. So whenever you have a base class, whatever you have in that class, derived will have it, and you add more features to it. Be clear on that? So what I want to point out over here is that although derived is deriving everything from the base class, it has access and it has everything that a base class has, but with controlled access. What do I mean by controlled access? It's like I have everything my father, but whatever my father has is mine, which means I can use whatever belongs to my father. But in reality, your father has a Porsche 911, you're not allowed to touch. You can ride with him, but you cannot drive the car. There is this Ford Festiva $2,000 car, everybody can use. Family can use it. Your neighbor can't, it still belongs to your family. But everybody can use it, okay? But the good things that parents have, children are not allowed to touch it. It belongs to them. So privacy still exists. That's why in a base class, you can actually mention what belongs to the family and what does not. So whatever that is private, we know in a class by default it is only for the base. Now this is a new thing that we didn't have before. If something is protected, only for family. which means children, grandchildren, anything like that. So the protected ones over here, base can directly access it as if it is its own property. No problem. So accessible for only for family, and public is for everyone. Obviously, when I say for everyone, anything you put in public, people can access, like anyway. In derive, it's the same thing. So remember that. This is a universal rule that we have. This public thingy that you have over here, you know nothing other than that. Don't ask me, can I do class derive private base or protected base? The answer is yes, but it's too rich for your blood. The only thing you do is public, and that's the only one. We good?
Yeah.
Now that this is the syntax for it, now how we access everything that we have in a base class and so on and so forth, I'm going to use the animal kingdom to talk about it. So we understand the syntax of inheritance. We understand the concept. Now how we actually write the code, we're going to go to that imaginary pieces that we had. So essentially, I'm going to go back to what we were talking about when I talked about an animal, and I said, first we have, right, not that one, please. Okay, there we go. Okay, so I'm going to go to the header file. So I have an animal over here. These two things ignored. That was just for you to practice and go enjoy your time with the class and try to see how things work. We created a class. We said the class, for me, an animal is something that has a name and it can act and move and make a sound. That's what I call what an animal is. You can access an animal's name using the query, the getter name, that essentially returns the name. You can set the name of the animal using the thing that you have, the getter, the modifier that you have, the setter. And obviously, I have an animal constructor that can either create a nameless animal or put something. So very simple class I created over here, and that's what we have. Where is my animal class thingy over here? There we go. Okay?
Can I ask you about const?
No, it's not now. Later.
Okay.
You're talking about this?
No, const. Yeah. I mean, I know what it does, but when do you? Just there's a good programming convention. I'm constant.
So let's not spam our thoughts. Okay, our focus is on inheritance, not those. We'll talk about. Ask me later. I'll explain. So, so now we have our class over here, and we're good. Let me see. So essentially, the constructor receives a C string, sets the name of the animal, and if the debug is on, we talked about what debug is, a flag, we set it on, it shows us messages so we can trace. If the flag is on, it's going to say creating name the animal. It's going to say what is the name. If where is it? We have a copy constructor that we don't care, and we have a copy assignment that we don't care because we are talking inheritance. I have a setter and a getter. So we have a setter over here that copies the animal name. We have a getter that returns the animal name. We have act that acts like an animal, move like an animal, sounds like an animal. Good? Right? Very simple and straightforward. So that's our class, our base class for all the animals. Now that we have that one, what we are going to do, we're going to change that to a base class, which essentially means now I want to create a cat out of an animal. So I want to say a cat is an animal that has number of lives. I can create a cat by default, or I can create a cat with the name and number of lives. I can always have the exact same method I have in the base in my derived one. If you do that one, it shadows it, which means the animal's act is no more. This will happen. You should be able to do that. When you have a base class and you are deriving it to a new class, you may need to make the things it did before to do it in a new way. My father was a teacher. He used to teach mechanics. I'm his son, therefore I'm a teacher. When I come over here, should I teach mechanics? No, it's C++. So my teaching method overrides my father's. That's a horrible example, because me and my father, there is no inheritance. Me and my father are really, are both objects of male human being. Okay? There's nothing like that. So there's no inheritance. Farther than mammals, yeah, that's inheritance. I'm a mammal. Okay? I'm a human. That's inheritance. Okay? But me and my father, that's not inheritance. Actually, my mother had the method called birth that returned the human, and that was me. Okay, so there is no other. So the reason that I use the teach thingy, because it makes sense. Okay? So a cat is an animal. I can say act, so I'm overriding the act, which means when a cat acts, it's not like an animal. When I tell the cat move, because the animal can move, right? I'm not going to implement it because cat moves like an animal. There is no implementation required. I'm going to say make a sound. Obviously, the cat sounds differently like any other animal. I have to mention how it sounds, so that's going to be different. It overrides. And also, it can have extra stuff that the animal doesn't have. You add features to it. There is no problem with this. We good? Okay, now.
So it inherits all the methods from the previous class, or you can overwrite them with new or different methods?
You can add features, or you can keep it the same way. Anyways, so I have the animal over here, and as you see, I made few modifications. The name is private, which means the cat cannot directly set the name. It's not accessible to cat. But I have a protected setter. So the setter in animal is protected, which means the cat can use it, but others can't. No one can change the name of a lion and make it a, I don't know, ostrich. You can't do that. My lion is a lion. You cannot change it to a dog. It's like it, you know what I mean? So that's what we are doing in here. So essentially you cannot change it, but the rest, as you see, it stays. Okay? So if you look at the code for the cat, you'll see exactly how it's implemented. I'm just going to bring up the animal one more time. So an animal can, when the constructor sets the animal and says, I have no name, the default constructor, no argument constructor. The one argument constructor sets the name. The getter gets the name. The setter sets the name. Act says act like animal. Move says move like animal. Sound says sound like animal. And the destructor just has a debugging thing. Absolutely no need for destructor because this doesn't have any resources. Why do we have it? So we can open it up and see when things are getting created. So we can understand the destruction and creation. Now, if I go to a cat, that's when I see how things are happening. First, the constructor that I have for the cat. So what did I do in here? I simply say, hey, cat has number of lives, so I initialize. We call this initialization area. Remember that? Yeah. Okay? So in the initialization, I'm setting, if you just create a cat, it has 9 lives. That's what we have, right? Now I'm going to say name, Garfield. So if you don't say what, the name of the cat is Garfield. You're not old enough to know about the comic thingy, but Garfield used to be. Anyways. So I put Garfield. Then I'm going to say if debug is on, I do this. I show the number of lives. Otherwise, I just create. When I create a cat with 2 arguments, I am passing the name and number of lives. Okay? I am passing the name and number of lives. If you look at the initialization area, I have something weird. You see that? I'm saying animal, the name. It's as if I'm calling a constructor. I told you cannot call a constructor, correct? But I'm not calling it. This is the initialization area. So I'm essentially telling to the compiler, when a cat is created, the animal part should get instantiated like this. So remember, if I am building If I am building a motorcycle, a bicycle will get created within. You follow what I'm saying? So I need to somehow mention if it's fat tires or if it's not fat. So I have to mention all the things that I am doing in a constructor of the motorcycle. So when you are creating the motorcycle, how the bicycle within should get created. That's what happens. So at initialization, you can not only initialize the attributes, but most importantly, you can initialize its base. This is a common horrible mistake. This is a common horrible mistake. It's not an initialization area. What does it mean? I am creating a cat. Because I'm not saying how the animal is getting created, animal will be nameless. It's going to be defaulted. So it's going to create a default animal. Then at line 21, it's going to create another animal that doesn't have a name, it doesn't have any handle, puts the name for it, and immediately that animal dies. It has nothing to do with the cat that I'm creating. And then it goes about the rest. So this is a very, very common mistake. Remember the screaming that I had? Constructors cannot be called. A constructor's job is in its name. When you think you are calling a constructor, what it's doing is actually constructing. It's not calling. So if I say animal something, it means create an animal for me. Not that I'm initializing anything or setting anything or calling a function. We good? Yes.
So anything created by inheritance method, you need to have these two lines.
Not necessarily. Sometimes when you create the derived class, you want the base to be defaulted. You're not writing it.
Maybe it's different. It's something different. You have to have.
Yes, if you want to customize the base, of course it must be that.
Okay.
That what you said is golden. So we have to say like this, not two lines, you have initialization area. So we have to always mention, if you are constructing a derived class and you want to customize the base, you must have the constructor in the initialization area, at least. Be good? So now, so this is common mistake. Don't do it. So I'm going to put this back where it belongs. And remember, in initialization area, what is being initialized must be in the same order of the things that exist. A cat is an animal first. So first you have to initialize the animal, then you have to initialize other things. Yes, sir?
Can you go back to the previous file? There's a question with the thing they said not to do with the constructor in the body of
Mhm.
yeah. So if you just as an experiment, if you did like dereferencing this equals animal the name, does that set it to like does that create a
Yeah, that's a very horrible way to do the same. Why is it horrible? I'll tell you why. So this is what happens. So can I answer that question when I'm teaching derived classes with resources? Because if I teach it now, I have to talk about copy construction, stuff like that. The answer is it's possible, but don't do it. Don't.
So, for example, in this case, how do you check the logic? Because you have two different constructors. So, normally, for this, you
Give me line number when you're saying.
right. So, normally for line 18, you check if the name is valid, then you like create new memory and then set it. But because you're passing the base class, how would that work?
Oh, so you want to check to see if the name is valid and then send it to the base? How can you do that? You can't. The answer is you can't do it. There are two ways that you can, but you can't do that. I'll show you the code that you can, but if your design is proper, the part that is responsible for validation is the animal.
Okay.
You are not supposed to validate and then give it to animal. That's bad design. If the base class cannot validate its own name, then what the heck, right? Or if you want to do that, then you simply default the base, and then you use the setter name to set it after validation. So if you must, he says, what if I want to apply some validation on number of lives? Like, for example, if number of lives is greater than 9, it's not supposed to happen, right? So this is what I'm going to do. First of all, C++ does that. C, not C++, provides that for you. I can simply say over here, if this is greater than 9, right, then it's 9. Otherwise, it's number of lives. So that problem is fixed, right? Right? So now this problem is fixed. I'm saying if the number of lives is greater, or I can even say greater than 9 and less than, so you can write any condition that you want. So this condition essentially conditionally sets the number of lives. So if it's greater than 9, or if number of come on, you can do it for that. Seriously? Number of lives is less than, say, 1. At least it has to be 1. Yeah. If it's less than 1, then set it to less than 0. No, 1. If it's 1, it's good.
We cannot have half-life.
No. No, that's integer. Integer is going to take care of that.
Oh.
So it's not going to be, I'm just thinking, I have OCD when it comes to stuff like this. You see, I'm sitting over there thinking about a stupid example that I'm writing over here. Just write the one and be done with it. Okay, so what I'm saying is that if it's invalid, it's 9. If it's valid, then it's whatever the value was. We good? So that's that, yes.
What does the initialization area do exactly?
It initializes the attributes.
Okay.
Okay, so now in here for the name, if I want to actually do the same thing, I can say if it is not null, then it is the name. But if it's null, it's no name. Right? I could do that, but I'm not going to do it. If that's the reason, like you cannot finalize the name, you have to do more investigation or more validation. You simply don't set it, and then you use your validation. If valid, whatever the validation was, now you're going to say base, which is animal, name, and the name. So you have a setter over there to set it for you. You follow what I'm saying? You use, if the name can be invalid, then I'm sure that the design is supposed to be in a way that gives you access to somehow set the properties after the fact. Okay? But the good design says, don't fiddle with it. Pass it to the base. Base is responsible for validation, unless you want to add some extra validations. Do I make sense? Okay.
So it's, I mean, I know this is a silly question, not silly, but it's like the equal, setting something equal to something, except it basically runs a constructor and does a bunch of other stuff. The initialization area is for putting stuff that you need to sort of do more complicated stuff with. Right?
Initialization area initializes. What is the difference between initialization and setting? Tell me.
It runs objects.
What is the difference between initialization? Tell me, what is the difference between these two?
Oh yeah, I see.
What is the difference between the two? This is initialized, this is not.
Yeah.
This will come to life with 10 in it. This will have garbage in it left. Then the garbage is overwritten by 10. Initialization, setting. So if you want your properties to be initialized, not set, you initialization area.
Yeah.
Okay?
It runs objects essentially.
Okay, so now, animal,
It runs constructors.
the name. Are we good down to this point, people?
Yes.
We good? We're okay? All right. Act. I am overriding the act of the animal. I'm going to say act playful because animals just act, but cat acts playfully. Give me a break. I'm just giving examples, right? Move, I'm not going to override it because cat moves like yada yada. If you remove this, then it's going to override. Remember, I'm not saying overload, I'm just saying override. What is the difference between overload and override? All right. Maybe. Okay.
When you overload, you change the way how like an equal would assign something. When you override something, you change what was already in there before.
It replaces the
Well,
old
I'm trying.
method.
You're trying to answer, but that's not the C++.
It replaces the old method with
When
the
we
new
do
method.
overriding, the type never changed, but overloading, the types changed.
Thank you. Thank you. 1% for final. Okay. When you overload, the signature changes. Override, there must be identical. You cannot override two neighboring functions. That doesn't work. You're going to get an error. You can only override in the hierarchy. If the child has the same method as the parent, then the child's method will be called. The parent will be overwritten, if that's the word. Okay? Remember that. So override, same signature. Overload, different signatures. We good? Okay. Now, for sound. Cat makes a sound like an animal, but adds a meow at the end. So in this one, I am not only overriding, but I'm reusing the animal sound. You see this? That's the difference. A method of a class is executed using dot outside. So you say animal A, you say A dot sound, right? But when you want to call parent's method explicitly, remove the confusion of overriding, you use animal scope resolution. It means call the sound of my animal part. Classes, scope resolution, objects, dot. So the apostrophe S that we have in English, Fardad's head, okay? Fardad's head is dot, okay? But Fardad's dad teaching is dad's teaching is dad's scope resolution teach. So if you call in my teaching, if you call dad dot scope resolution teach, if you call dad scope resolution teach, I'm going to start teaching mechanics.
Doesn't that make two sounds though? Doesn't it call them?
Yes, of course, it does two sounds. So it sounds like an animal and says meow, which is perfectly good. Okay. Obviously, there is a play that has nothing to do with the animal. It's just something extra. We good? Are we good? Are we good? One? Are we good? Two? All right. All right. So I'm gonna go to. I don't know what the main over here looks like. So there we go. So I create over here an animal A Coco. So where is it? There we go. I hope you two guys are talking about this, what we are teaching, right? Back there. Okay, so we're gonna go like this. Okay, so animal Coco, that creates an animal, we know that. Overriding the empty name with Coco, creating Coco the animal. So that's because the debugging is true, it's showing what's happening. Okay, now when I'm creating the cat, overwriting the empty name with floppy, that's the constructor of the animal being called. Now creating Fluffy the animal as a cat with 5 lives. So this is the constructor of the parent. Sorry, this is the constructor of the parent. This is what is added in the cat. We good? I'm going to walk through it too, by the way. So I'm going to actually walk through it. First, I'm showing you what's going on. Now, when it's defaulted, overwriting empty cat with no name, defaulting to no animal, overwriting yada, yada, yada. So again, it's actually, that one is good. When reference is created, nothing happens because it's just a new name for the other one. Now I'm going to say gact, act playful Garfield the cat. When I say agact, it's the same thing. Oh, sorry, ag is the cat. Don't look at it, don't look at it. Ah, close your eyes, close your eyes. Okay, okay, I have to mention something. I forgot to mention something. Excusez-moi, pardonnez-moi. I have to explain something. I'm Fardat, okay? In object-oriented world, if you call me Mr. Solimanlu, I'm going to act like my father. So if you call me Fardat teach, I'm going to teach C++. If you say Mr. Solimanlu teach, it's going to kick in. It's going to completely forget that I was Fardat. It actually goes to my base part. Same thing over here. Forgot that I actually wrote that. So when I'm saying animal reference AG is equal to C, I am referring to a cat as an animal. So cat completely for this, if you access the cat, the Fluffy the cat, using AG, it completely forgets that it's the cat. It's going to act like an animal. You follow? Am I making sense? So remember this. One more time. So when I say gact, that's the cat that is. Why did it not clean thing? Okay, wait. Okay, let me just close and open it. There's a bug in it. Again, I'm mentioning it every single time that I cannot update it, my computer. It's one of the strange things that you work for an organization. They give you a computer to teach computers, but you're not allowed to update it yourself. Okay, so that's that. So I'm going to come back over here. So when I say gact, it's the cat that is acting. When I say agact, it's act like an animal. There is no cat. Although AG is pointing to a cat, the Fluffy, the one, the thing, right? When I say ccat, which is essentially AG, now it's going to be, okay? So as you see, cact, AG cat, potatoes, potatoes. The difference is that this only points to the, forgets being a cat, and the other one. Now I say cmove, because move was not, we didn't overwrite the move, it acts like the other one, but sound will. So it sounds like an animal, but says meow too. And play has nothing to do with the animal. You can never call play an animal because animal doesn't know what is play. Animal must become a cat to learn how to play. And of course, I'm going to do another a move. That's for the animal. It has nothing to do anything. Sound is sound. And at the end of main, everything is called in reverse order. Everything dies in reverse order. We okay?
So AG act is Fluffy acting like an animal? Like that C?
Give me line number.
Line 12?
Line 12.
AG is equal to C means that...
No, AG is not equal to C. AG is a reference, correct?
Yes.
So AG becomes an alias for C, which means you have a cat named Fluffy that you can actually refer to it with AG instead of a cat, an animal. So if you tell to the Fluffy, do something with the AG reference, it forgets that it's a cat. It only is, all the animal stuff is going to happen. Okay? We go down to, yeah, oh, okay. Yes, go ahead.
So, but information about the animal is the same as the cat, right?
the shared
Name,
information.
The name or the something.
The question is wrong. They are the same object. Why you are saying they are the same? When you are saying the information for the animal is the same as cat, you sound like they are two different objects. They are the same object. You're looking at one. It's like looking at this with eyes and then put glasses on and looking at the same thing. You are just looking at the same thing in different ways. So the question was wrong. That's why I corrected it. I cannot say AG is the same as the cat. They are the same. They are one object. The only difference is that now it's going to just behave like its parent, like its base.
Everything cat does, maybe animal can't. Like male, cat only can, but the animal can't. So you only can do that.
To a cat.
No, to the AG.
Yes.
Okay.
Okay.
Alright, so same thing, line 12. So AG is a reference to C. But if you do AG dot play, which exists on C,
It's not going to know it.
is it a compiler?
No, yes, it's going to. Let me actually do it. You're right. If I say over here AG play, it doesn't know that if I say AG dot play, it's going to say, what the heck you're talking about? I don't have a play. It's a syntax error. If it shows that it doesn't, anyway. So this is syntax. An animal doesn't have play method. Okay, we good? Okay. All right. Now, I just showed you the reference thingy. Let me close all tabs. Let's see what happens if we put these things in pointers and reference. So I just showed the reference. I shouldn't have, but I showed it. Now I'm going to kind of put more emphasis over it. So animal is the same, as you see, nothing different. Okay? RBSTDS, let me just change this because I did change it last time. I didn't do it. Give me a second. Control H. STDS will be changing to Seneca. What is this? Match hold no. Case sensitivity, yes. And it's going to be entire solution. Give it a second. Yes, replace all. Okay, so that's that. 76, holy moly. Okay, now I'm going to go lowercase STDS. And I change that, pardon me.
How do you use that panel? Control what?
Magic, I go up, Control H. Control H. If you don't know these things, go to Edit, and Edit has all the stuff that you want. So Seneca, you were just thinking that I copied my friend's thing and I wanted to change all the names of the function. How can I do it quickly? This is how you do. Okay, so Seneca, and this is supposed to be a whole thingy, so I'm going to do entire solution. Okay. Replace in files cancelled. Some replacements were. What are you talking about? I hope it works. We'll find out. So.
I think you closed it before it was finished.
Did I?
Possibly.
Bad boy, I am. Control H. So this is STDS. Okay.
I need to ask you about.
So what else did I need to change?
Oh, that's it, the namespace.
That's it?
and
Okay,
the
all right.
card.
All right, we'll find out. If it gives us error, we'll find out. Anyway, so that's my animal. Now I have the cat over here. And now you see the cat over here has everything. It overrides everything and has a play. So that move that I blocked over there, I didn't do here, okay? Because I want to make another point. Now, let's go to main. See what I'm doing? I'm creating cat, pepper, okay? Then I'm creating animal pointer AP is equal to new cat. I can, right? Because cat is an animal. Now I'm saying animal reference AR is the same as P, which means AR becomes a new name for P. And of course, I have an animal over there just for the heck of it. Okay? Now, this is an important moment.
Go back up.
So, I don't know what that using namespace is doing up there. I have to bring it down, but that doesn't matter. Okay, so let's start. And then when we start, take a look at this. So here, cat is created, no doubt. Over here, although the only handle that cat has is the animal pointer, but still a cat is created, right? So remember, cat is created. Now the animal reference, and here is the animal by itself. So when I say P act, P is essentially a cat, therefore everything's going to act like a cat, right? Now I'm going to go to animal reference. Because it's animal reference, everything's going to act like an animal, right? This is the part that we have problem. So with AP, I'm going to go like that, and as you see, it's acting like an animal. Although we know animal pointer is actually cat, Tom the cat, right? Problem over here is that there is no way for you to access the cat anymore. You created a cat in an animal pointer, but it's a waste. Not only waste, but take a look at this. I am deleting the animal pointer. Pay attention to the destructor. What got removed?
Tom the animal.
What happened to the destructor of the cat? It's never called. What does it mean? Memory leak. Because the only handle you have to that cat is an animal pointer. When you delete the animal, it only wipes out the animal part. The cat part remains in memory. So that's bad. Okay? Obviously, if I continue, you'll see that everything else is deleted properly. The animal is deleted properly, and the cat and everything. So the cat's deleted. Everything is deleted properly. Are we good? How do we fix this problem? Because we need to make sure that we can refer to stuff dynamically without losing a leak, right? Without having a memory leak. So how do we do it? Now I want you to pay attention. And also, all the behaviors that I had for that animal, for that cat, is completely lost when I have an animal pointer. Wouldn't it be nice if there was a mechanism that I could set so whenever the compiler is using a pointer to a base class, it could check to see if it's actually pointing to the derived classes of that base and not the base. And if any of the functions have a better version, recent version, those want to be called first, which means if I'm pointing to a cat using an animal pointer, I can decide which functions call should be the most recent one automatically. Like that, I could do amazing updates. Take a look.
Even if we do it and in here the recent function is the play.
Thank you. Thank you for that question. When you are pointing to a class, an object that sits within a hierarchy, whatever hierarchy, it could be you have a base, you have a derive, and you have a most recent derive. You have a grandchild, you have a grandparent, parent, child, and something like that, right? If you have something like this, whatever the reference or pointer is, the closest method to that will be called. So if it's a pointer to a base, the base methods will be called. If it's a pointer to the most recent one, the most recent. If it's half, the half. And it forgets everything else.
Could you cats?
I can do that. I can actually say if anybody is inheriting from me, all I need to do is to add a virtual to the beginning of my functions. Any function that I want you to listen to me carefully. This is going to be a question you'll be asked in an interview. How can you guarantee that no matter how you point to an object, always the most recent method is called? That's through virtuality. So if you make a function virtual and the compiler looks at it and sees what you are pointing to is virtual, it looks, do I have a newer version? If it does, then that one's going to be called. I'll remove the virtuals completely, then I'm going to bring it up. The code over here and the other one, the only difference is these three words. Otherwise, it's identical to the other one. So if I run this program, let me just see what the main looks like. See, this is the thing. I have some more stuff added, but it's essentially the same thing, right? Now, if I run this program, if I actually run it like this, okay, if I run it like this, animal, yada, yada, I created all those things. So if it's animal, it's all animal. When it's a cat, it's all cat. When it's a cat pointer, it's all cat because it's a cat pointer. When it's an animal reference, it's all animal. When it's an animal pointer, it's all animal. When I'm deleting the cat, cat is deleted. When I'm deleting an animal pointer, only an animal will be deleted, even though it has a cat part. And when I say tickle the animal, it passes the A as a reference to A. So A over here, let's call it R, reference. So R over here, okay, sounds like an animal no matter what is passed to it. See, over here, P is a cat. I pass it over here, and it says sound like Pepper the animal, and ha ha ha. But it should have said meow. It didn't. Okay? Now see what's going to happen. I'm going to go to animal, and I'm going to say, hey, sound is virtual. It means this is not the real one. If a newer version exists, call that one. And from today till the moment you die, when you write C++ code, all your destructors must be virtual. Unless explicitly you do not want inheritance to happen. When you make a destructor virtual, you guarantee that no matter how the object is pointed at the moment of destructor, all destructors are called. Essentially the most recent, therefore, okay? So when you kill a cat, the animal within dies. But when you kill the animal, the cat part remains. So that has to be always virtual. Now, remember, I only added virtual to the animal, to the destructor and sound. Now let's see what happened. What's going on? Okay, stop. Let's do it again. Okay, so I'm creating everything, fine. When object is animal, reference in animal, I don't care if something's virtual or not. I don't have inheritance. So nobody cares if act, move, sound, anything is virtual. You have a coffee cup, you call it a coffee cup. It's coffee cup, done. You don't need to do anything. Okay? Everything is the same. Inheritance do not exist. That works. Wait a minute. There we go. That's better. Okay, so everything is the same. Now, when is a cat and a cat is pointing, I don't care about virtuals. Why? Because I have a cat, The reference is a cat. Why do I need to care about anything? So when the object and the reference, when I say reference, I mean something that I'm referring to, either pointer or reference. So the object and what I'm referring to it are from the same type. I don't care about virtuality at all. Zero interest. Same thing over here. For the cat, everything is a cat. I don't care about anything. But now, this is the same. I have a cat and a cat pointer. I do not care. Everything is a cat. But here, I have an animal reference to a cat. Now, the ones that are virtual, the latest version will be called. Act wasn't virtual, it's animal. Move wasn't virtual, it's animal. Sound was virtual, that's the latest version. The same thing for the pointers. Act wasn't virtual, move wasn't virtual, sound was, it works. Delete cat in a pointer of a cat. I don't care, everything's fantastic. But delete animal pointer that points to a cat, when I actually go, I'll see that actually the cat's destructor is called now. Unlike the last time, that was the animal only. So, and also for the tickle that I was doing over here, when animal is passed as an animal, I don't care, it's an animal. But when a cat is passed like an animal, now the sound is virtual. Therefore, it's going to say meow. So, what did we learn? When you are creating a class that is intended to be a base class one day, you always take a look at the methods that you are creating in your class. You think, will this method ever need 1 in a million to be improved in next generation of my class? If that's the case, you make it virtual. That guarantees that the latest version of that will be called at all times, no matter what is pointing to what. Yes?
So only the base class, the cat class, no need virtual.
When I say a base class, I mean base of anything. So if I have A driven from B, C driven from B, B driven from A, if you make something virtual in B, then everything after B is virtual. When you make something virtual in A, then everything after A is virtual. So you'll see in future that I'm going to extend this inheritance. If animal has a virtual sound, you don't need to make the sound of the cat virtual. It will be virtual automatically, although it's a good practice to write virtual. If the base class carries a method that is virtual, that's a transitive thing. All the methods with the same signature will be virtual for the entire series of inheritance. Okay? So, that's that. Now, if I make everything virtual, now in my code, no matter what I have in here, always the latest version of the code will be called, because everything is virtual. So it always acts like it's here, it's actually coming down. It always acts like a cat with no exception. And please don't tell me, so just in case, let's make everything virtual. No. Sometimes you do something in a base class and you say, hey, this method should not change. It should always remain the same. If that's the case, don't make it virtual.
So the thing that changed here is where the time the cat become playful, like
It's the animal.
It was animal.
Yes. You have to plan it in a base. There is no way in a derived class that you can enforce this. It's always the base class. It's, oh, when you think about it, it should be the decision of the person who is being inherited to decide what of me should go forward, right? And what should override me. And that's what it is. Anybody wants to take a break for 5 minutes?
Sure.
Okay, so 5 minutes, and we'll come back and we continue, okay? And then I'm going to make you happy after when you be done. I'm going to show you something interesting. So for now, I'm just going to let's resume. All right. So wait a minute. I have a question. Humans can speak, right? Can you create an object of type human and ask a human to speak? Can you implement? We know that humans can speak. If I ask you to write a code for a human that has a method called speak, can you implement that method?
Does it descend from animal?
No, I'm just talking about the human. You don't know the language, right? So I cannot implement the speak for a human unless I go a human that is not only from China, but which part of China, so I know. So in many levels of inheritance, you are 100% sure that the method exists, but you don't know how to implement it. Its existence is essential, but you cannot yet implement it. Do we understand what I'm saying? Yeah. Okay. So how do we implement? How do we enforce it? How do I enforce if I create an object called a class called human with all the things that the human can do, and I implement them all? Then I reach to speak and I say, wait a minute, can't do this. But I want it to be there. Otherwise, a human cannot be instantiated. When I'm talking about, like, I'm saying, let's say, I give always this example, everybody laughs at it, but let's say you are the best in the world, you're Michelangelo, and you can sculpt anything you want. If I told you create a sculpture of a human being, can you? Yeah. No. How do you know if a man or a woman? How do you know you want to do the features for it? You follow what I'm saying? You cannot instantiate a human being until it's finalized what it is. If I told you create a mammal, can you do it? Heck no. I know what a mammal is. I know how do they reproduce, but it has nothing. That's the only thing I know. The rest of them are, I don't know. I have to find out what you want me to create. Any base class that for sure is capable of doing something, but you don't know what, we call that an abstract base class. It's a design. It's a requirement. So you essentially create a class with series of methods that are hollow. They are empty. You write the signature of the methods. I want this method to be there. But you're not going to mention it how. That class becomes a design. It means that class cannot be instantiated until it is inherited into another class that implements all those hollow methods. Otherwise, they remain abstract. Again, if I create a human being, and out of that human being, I create an Indian human being, can I still instantiate? You know how many languages they speak in India? It's impossible. I have to keep going until I get to a definite answer. All the series of hierarchy, I have series of abstract base classes back to back until I get to what we call a concrete class. A concrete class is that a class that all the methods inside the class are for sure and 100% you know how they work. And then you create it. Those classes can be instantiated. Back to our example. I have a class called animal. The animal can act, can move, it can make a sound, but I don't know how. You see that? Equals 0, it means my wish list. If you want an animal, you have to inherit this and then implement the sound the way it receives nothing and returns nothing. You have to override this, what we call pure virtual method, this hollow method for that thing to exist. Which means an animal by itself cannot be. You cannot instantiate it. If you write animal A, it's going to say, cannot create an instance of an abstract base class. Okay? So when you look at this, now I have a cat, and as you see, cat is implementing the sound. And I also have a dog. Dog is implementing the sound. So dog and cat are concrete classes, but animal is not. Now, what is a beautiful thing about these virtual methods, pure virtual methods specifically, so when I go to main, if I actually do this, it's going to actually give me an error. But now what I can do, I can create an array of 4 animal pointers. I can put a cat in one, a dog, a cat, and an address of another dog that I had over here. Now in a loop, I simply say, hey, animals, make a sound. Because that pure virtual function is virtual, each one will automatically call the best method available. A dog's gonna woof, a cat's gonna meow. Automatically. I do not need to mention which one it is. Take a look. So back to implementation, as you see, animal doesn't have any implementation for the sound. Why? It's pure virtual. The dog, the cat has it. Sound says meow. The dog has it. Dog says woof. Now, in my main, when I'm actually running this, 3 years later, I create a series of animal pointers and I put different types of things in it, cats and dogs. This animal reference is over there just for the heck of it. Okay? Now, in here, first one, I'm going to say make a sound. It's going to be a meow. The second one, it's going to be a woof. The third one, meow. Fourth one, woof. By looking at this line, can you tell me what sound is going to come out? It's impossible. Now, this is real polymorphism. Absolute identical thing. No overload, schmorload stuff, no coercion. Nothing like that is happening. By virtuality, automatically the proper version of the sound is called as the program proceeds. That's, when I say that, I get goosebumps. This is how everything works in the world. This is how you tell me, do your job, and I start teaching. You go to an admin person, say, do your job, it's going to do administrative stuff. You're going to go to a chef and say, do your job, they're going to cook. Because employees have a pure virtual method called job. Do your job. And that pure virtual method is implemented based on what type of employee do you have. Are we making sense here?
Why is it called pure? Is it equal 0?
Pure because it's pure.
No, but to declare it, is it equal?
Yeah, it's equal 0. It doesn't have a body. There's no body in there. Now,
That makes sense. So
I'm so sorry that Amir went, because this is the most important part that comes exactly after this, and this is where everything clicks, and he had to go. Now, take a look at my animal. It's got nothing. Doesn't have a name, doesn't have anything. I'm saying animal is a thing that can act, move, make a sound. Even the destructor is nothing. I'm just saying, they've created default destructor and do nothing, just make it virtual. This type of classes that are all pure virtual, we call them interfaces. They are pure design. They have nothing other than requests in them. It's as if somebody's sitting, thinking hard how an object is supposed to be in general. And they create a class that only has pure virtual methods. These type of class mostly don't even have a CPP file. They're just a header file. Yes?
So it's called interface. It's called interface, this class or this type of class.
It's called interface. Yeah.
Okay.
But interface is an object-oriented terminology for it. The reason we are teaching it to you is that in future, when you're going to graphic CUDA programming and C++ programming that are more advanced, you need to understand what an interface is. From C++'s point of view, one pure virtual, all pure virtual, it doesn't matter. For C++, that's an abstract-based class. C++ doesn't have anything called interface as a keyword. For C++, they're all the same. Yes?
Can the interface have data numbers?
I would say no.
No.
Then it's not an interface anymore. How you want to set them?
basically saying.
When you have no action, how you want to set them,
Yeah, that's a good point.
right?
Create a bunch of classes from it that do what they should do.
So we look at this. Now I have an animal. Now I have a pet. Pet is an animal who has a name. That makes more sense. Pet is an animal who has a name. It can move, make a sound, and it can do all this stuff, but I didn't say how it's going to act, depending on what type of pet I have. So pet is still an abstract-based class, but it's not an interface, because it still have unimplemented stuff. You can actually do this. You can actually come over here and say, I think it's in resource files. You can actually create a class diagram out of it to exactly see what they look like. You see, an animal is a pet and cat is a pet. Okay? Now I can put so I can create an array of animals, and whatever I do in here, the latest method's going to be called, or I can create an array of pets. It's the same. Still, what I have in there are virtuals. And the source code for it is almost the same, so please go through it and you'll see how everything works. Okay? One of the one of the amazing stuff that you can do when you have interfaces like this, first of all, take a look at the hierarchy now. So I have an animal, I have a pet out of animal, out of pets I have cat, goldfish, bird, out of birds I have budgie. And each one has its own features, but regardless, they're all animals. You follow what I'm saying? So even if I say move over here, move from here, comes to here, comes to here, comes here, it's going to be flying. But when it comes over here, it's going to be running. If it's a kangaroo, it's going to be hopping. Whatever you want to do, right? So again, when you look at this, or not pet, but if you look at the main in here, see what I'm doing? I'm creating an array of animals, and I'm going to put a cat, a budgie, and a goldfish in it. And when I run the code, Three years later, when I run the code, this is what I see. I have all the animals created. Then I'll come over here, and I'm going to say act, 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 and I have completed three different types of things. 3 animals, 1 playful, the other one, whatever, okay? We good? Okay. This saves time and lets us write much less code. Why? Take a look. You see that animal thingy that I have? What did I do? I overloaded the insertion operator for an animal. And an animal cannot exist, but I'm overloading something for it. Why? Because when the reference of an animal is passed, no matter what type of animal is executed using this, it's going to do whatever you want to do. So I told you sometimes they don't have CPP. This one has CPP. Take a look. So the CPP file of a part of animal only overloads the insertion operator, calling all the pure virtual methods. Doing this, I do not need to overload this for any of its descendants. A goldfish can be printed, a dog can be printed, a cat can be printed. All of them can be inserted into cout. And because cout calls the most recent, the latest version, automatically it's going to work properly for them. Take a look. So when as you see over here, I am creating a pet array of cat, budgie, and goldfish, not even an animal, a pet. But because animal is overloaded, pet works for it too. And one by one, I'm printing those things out, you see? Now, this one, I'm going to actually walk through it. So when it actually called, it goes to the animal operation, animal insertion. But what I have over here is not an animal. It's much more. When it actually acts, it calls the latest version of it, which is budgies. Therefore, it's going to act like a budgie. And for the last one, when it's called, now act is act of a goldfish. So as you see, cout is overloaded for all of them. And that's the beauty of virtualism. You go to the base, you design everything for your base, all the descendants will actually inherit. That is why you can do crazy stuff with your file system. The cout that you had, because of this fact, let me stop this. Set a startup project. Because of this fact, I can actually come over here. So let's actually write something over here. I'll put with Alt F8. What do I call this? Inheritance syntax. See what I'm going to do now. Take a look. I'm going to write include IO stream, include F stream.
What is upstream?
You'll see. Then in here, I'm going to say OF stream, which is a child of O stream, which is cout. I need using namespace std. Give me a second. I'm going to say OF stream, F out, like cout. I'm going to say over here, output.txt.
That's what it's doing.
Now in here, I'm going to say F out, hello, I am writing this, and I'm going to go to new line. Then I'm going to say F out. What can you do in cout? With 20. F out fill. Set fill or fill. Dot fill with asterisk or with asterisks. F out set F iOS right. F out, I don't know, right. And F out, obviously, because I did that, I have to say onset F iOS right. And F out dot fill space F out I am done and L. And when I run this program, nothing's going to be shown on a screen. Why? Because when I take a look at it, I have output.txt. Ta-da. Anything you did with cout and cin, you can do it with files. Why? Inheritance. Why? Everything you have done with cin and cout, they're all virtual. Therefore, their children, IF stream and OF stream, can do the same. I don't need to teach you how to read files. All I need to do is to say, this is the constructor, go. It's even better because you don't have the stupid user to deal with. You're going to get a file perfectly formatted and you're going to see exactly what's coming. You program it exactly for that. You're going to read everything from a file. Why do you need the user? And if it fails halfway through, you just say, okay, record number 952 had invalid data. Please fix it. You tell to the client fixes it and comes back to you and you're done. You good?
Yes.
So first of all, let me fix that format. So that's right thingy. I needed to go and L, no, I didn't. That should be better. All right. And now, and as you see, do you remember files in IPC? You had to do fopen and then you had to do fclose. Where did the close go? I don't need to, because any stupid person writing the file class knows that they should close the file in a destructor, right? So it's going to close it, or you don't need to worry about it. But if you want to close it, you're welcome to do so. No problem. Now I can say ifstream fin, and I'm going to say output.txt. Now I can write over here something like what? Character str, say 81. Now I can say fin into str, and I'm going to say cout str. There you go. So it works exactly like thing, but the thing is that because you know exactly what your output is, you know exactly what your thing is going to say hello, because the limiter for that one is a space. You want to read it to the end? What did you use? Get line. Do a get line and it reads it to the end.
What does flush do?
There is no flush.
I've seen it in your notes.
There is no flush. We don't have flush. That flush is a different thing. It's not. It does not.
I think she means like, you know how new line makes a new line and end
You
line
write a loop for
makes
that. There is no. How did you flush? How did you flush with cin? Dot ignore.
Yeah, ignore.
So if I want to flush, I can simply say fin dot ignore, exactly like that, 1,000 characters, whatever, and \n. So it means read everything up to \n. Now I'm going to say fin str again. Oh, sorry, my apologies. Oh, God. I hate the person who did that. I'm going to highlight it. It puts it in the middle for some reason. Okay, and then I can say fout str again. So now if I run this program, you'll see that it's going to read the output. Oh, what happened? Did it work? Did it work? Did I compile? fin str fin ignore \n str. It should have worked. No, it should work. Let's see. Let's see what I've done. Control F5. Huh. Okay, I'll find out. So it comes over here, reads. There's no mystery happening over here. I made a boo-boo somewhere. So I'm ignoring Oh. Does ignore eat the \n? Does ignore eat the \n?
No.
I don't.
Yeah.
Does it eat the
Yeah, it
\n?
does.
Did I have two \n? Because this is hello, and this does it. It's really. It means there is a delimiter happening. Oh, right is. So what the heck? Why is it not printing it? Because I'm doing fout. I'm an idiot. It's cout. Sorry, I was writing it in a file that is closed. My apologies. It's always a mistake from me. That's one of the things that you should always remember. When something goes wrong, it's your mistake. Okay, now it's better. But your first reaction is that something's wrong with the program, with the language. It's not the thing. You did something wrong. Does that make sense? So that explains how we can use all these things. So this is essentially seriously, I don't need to teach you files. You know how they work exactly. Write your files, do whatever you want to do. And finally, at the end, I think, so interface, so yeah, the last one has constructors, messages, and all this stuff. You can run it and see what happens. Now, I said I'm going to make you happy. What I'm going to make you happy with is this. So let's go to the subject. The way I teach this, it has a very good side effect, which is this one. Courses, OOP244, and I'm going to bring up your addendum. Log in. So we are down to here. Finished everything. So we are on, we are finished by week 10, and the next one we're going to talk about is week 11. Classes with resources, so we are back on track. We good? Questions? All right. Derived classes with resources takes 3 seconds. Very simple to go through. It's just certain facts that I have to tell you. Essentially, it says in inheritance, when you have dynamic memory allocation in derived classes or base class, what happens when you copy stuff? We did copy constructors, right? Copy assignments, right? How do we do that? How do we deal with that? It's a very simple thing. I'm just going to give you like 3 different rules, and you know it, and it's going to be gone. So there's nothing extraordinary about it. Function template is easy. So we are almost done with everything in a semester. So in a week, we're going to be done.
What
Yeah.
happened to the quizzes for the second semester?
Pardon me?
When do the quizzes for the second semester happen?
They're doing it the day after tomorrow. When is your
Friday.
your Friday? So Friday you have quiz 3. I'll tell you what is it about again.
Those quizzes.
I'll tell you. I'll tell. Yeah. But it's going to be on things that we did before, not the quiz. That's all. I'll try to make the quizzes small, and so we are in week 11 now, right? This is week 11 now. Okay, so 12. So we have 3 weeks. In these 3 weeks, I'll try to do 3 quizzes, small ones. So we can drop one of them that is lowest, something like that. Okay, so give you some. Yeah. Good?
Yeah.
All right. Questions? Suggestions?
That's not. And we're in week 10.
Objections?
It's Remembrance Day. It's week 10.
We have a holiday again?
No, we don't have holiday.
Oh, we don't have a holiday. Okay, fine.
Today's Remembrance
Okay,
Day.
I'm happy. Okay.
Go
Okay.
stuff.
Guys, have a beautiful day. And